Hello. Okay. Good morning, ladies and gentlemen. Very warm welcome to the Honorable Dean and Vice Dean of Faculty and Mathematics and Natural Science, Universitas Negeri Jakarta. Thank you for being here in this morning with our online international seminar with second keynote speaker. My name is Dahlia Sukmawati and I'm academic staff of Biology Department Universitas Negeri Jakarta. I will be your moderator in this plenary session. This session will going to be 60 minutes, consists of 45 minutes presentation and 50 minutes discussion. All questions will be at the end after 45 minutes presentation. And for the discussion, please write your question in the Q&A menu. Before the question, please write your name and the institution or raise your hand. Today, we pleased to welcome our special guest as a keynote speaker, Direktur Institut Pembangunan Bioproduct Universitas Teknologi Malaysia, Professor Dr. Renat Hesham Enshasy. Before Prof. Hesham deliver his presentation, here's the video profile of the Prof. Hesham. Please. Okay, thank you so much. Thank you so much for the nice, very much video. Prof. Hesham is very great scientist with many kind of research and collaboration. But I want you, all of the participants, give some special things. Is I would like to information all of you for yesterday is very special day from our guest keynote speaker. Please, happy birthday for you, Prof. Hesham.
Thank you very much, Dr. Dahlia. Thank you.
Happy birthday for all.
Thank you very much.
All of us the best. Okay, today we have lecture from Prof. Hesham will deliver the topic with the title Techno-Industrial Platform Development for Production of Probiotic from Cell Bank to Bulk Powder. Prof. Hesham, the audience is yours. Please.
Thank you very much for your warm welcome. It's Professor Dr. Dahlia Sukmawati. Hopefully going to professor soon. I am very happy that's to be home. I say University Negeri Jakarta is usually our partners, and I love too much to come to Jakarta. And I'm very sorry it's for this pandemic not to come to you and speak with our friends and colleague University Negeri Jakarta, our partner university. For this, I would like to express my sincere thanks for organizing committee for this highly prestigious invitation, being one of your plenary speaker in this your international conference. And hopefully this is the audience today going to have interesting talk and learn something from my talk and giving some message back home after this one. Dr. Dalia, I'm going to share my screen, or you change the screen from your side?
We are.
I share my screen, correct?
Okay, please.
Okay, thank you.
Yeah.
Okay, today I'm going to talk about the Techno-Industrial platform development for the probiotics from cell bank to bulk powder. I'm now sitting in University Technology, Malaysia, not so far from Jakarta, just 2 hours flight, when the flight is back as a normal, hopefully soon. And we are Institute of Bioproducts Development, University Technology, Malaysia, as high CVE Center of Excellence in Malaysia. What I'm going to talk today about, I like to talk with you about, in general, about the probiotics, science and business, the market and the future trend, and the probiotic yeast and bioprocess manufacturing platform design. Okay, for this one, if you're going to talk about the human body, I think most of you who are not in biological field too much, when you're talking about microbes for you is something, a disease. But without microbes, we cannot live. We should understand that. If you meet someone on the street and tell them, okay, who is not non-scientist, and tell them, okay, you have a lot of microbes in your body, it means you scare him. You think about the COVID-19, you think about the bacteria, you think about fungus. But we need to think about the human body contains about 100 trillion cells, but only maybe 1 in 10 of those cells actually are human. And the rest are from bacteria, virus, and other microorganisms. And if you look for the genes, for those people who work with the genomes and genetic engineering, for each gene in the human body, we have 360 microbial genes. It means we are more microbes than mammalian cells. Scary, correct? But not scary, because microbes doing a great job in our body and we need them. Okay, in our human body, usually we think microbiome, when you're talking about human microbiomes, it means the whole. And when we're talking about the human microbiomes, we have more than 1 million genes in our body. People think for many years, probiotics are just in gastrointestinal tract. But now, with our increased knowledge about the human microbiomes, we find in every part in our body, we have a microbes. We have microbes in lung, we have microbes in the mouth, on the skin, we have a microbes in intestine, we have a microbes in our stomach, even under harsh pH, different types of microbes. And we say usually the first present from mom to a newborn kids is the milk, breast milk, which is full of microbes, which is lactic acid bacteria, bifidobacterium, and other microbes, which is start to introduce the microbial system to the newborn, which is play a very important part in the kid's life. When you're talking about the human microbiomes, it's, as I mentioned, in the oral cavity, in the nasal cavity, in the skin, in the genitourinary tract, and gastrointestinal tract. And this is in our body, we harbor about more than 1 billion of cells, which is microbes, which is helping us in our health and prevent a disease. Because the new theory of the disease, especially for not metabolic disease, but it's related to microbial disease, it's you need to have a microbes in your body to work against the external microbes, which is causing the disease. It means microbes for us is our army. Not only army, they play a very crucial role in the production of different metabolites, which is very necessary for our body. Therefore, you're talking about the human microbiome, which is the all microbial microbes that live and on our bodies, in and on. Because for many years, when they talk, if you have a skin microbiome, microbes in your skin is associated with a disease. But nowadays, skin microbiome is a very new area, maybe only in the last 10 to 15 years, and starting a lot of business related to this one, to have a healthy microbes against pathogens on your skin. They belong to our body and they help to support our health, they help to digest our food and provide many kinds of protection mechanism for human health. The gut microbes or gut microbiota is the most famous one. They work to extract vitamins and other nutrients we need to survive. And some vitamins, like vitamin K, which is need to be exogenous and produced by microbes. And other vitamins as well, to make it available in the body, they need microbes to produce. Also, they teach our immune system how to recognize the dangerous invaders and produce helpful anti-inflammatory compounds and produce a chemical that fight off other bugs that could make us sick. Like they produce many antimicrobial compounds like niacins and polypeptides antibiotics mostly are produced by lactic acid bacteria. And those are very important for us to survive. The other things, as I mentioned, that's production of the various bioactive compounds, which help in the microbes interaction. Microbes interaction, like in the right side, if you see here, I have a pathogen like Vibrio cholera, and I have lactic acid bacteria, and I have just to diagnose, and we compete together. Lactic acid bacteria can produce different antimicrobial peptides, which is helpful to attack the new invaders, which is not belongs to our body, and they are competitive exclusively and cell-cell communications. They have a different signaling and mechanism to prohibit the growth of the pathogens. At the same time, they produce various bioactive, like histidine, glutamate, and dietary fibers. They convert to other bioactive metabolites, which can be absorbed by the intestinal system for our body to be used. It means they make our food biorefinery in the intestine. Microbes help on that to extract the bioactive, convert the bioactive, and generate new bioactives. This is a 3 jobs of usually probiotics microbes in our body. If you need to talk about science and to understand science, go back to Greek. I like too much Greek language, even though I'm not speak Greek, but Greek is the mother language of science. Pro, it means for. Biotic, it means life. And this is the probiotic. And the first term of probiotic was first time in 1965. It means it's a new science. And now it's a new business. It's not only a science. And these are a substance secreted by one microorganism which stimulate the growth of others. This is the prebiotic, probiotic terms. And 1989, they improved the definition to alive microbial feed supplements which beneficially affect the host animal by improving its intestinal microbial balance. Therefore, you find many products now in the market under probiotic category to enhance our life and improve our life quality. When we administrate probiotics, we need to have specific microorganisms need to be viable and active. Probiotic products must be active, and we need to have a consumption of minimal amount of probiotic food, which is related to 10⁻⁷ colony forming unit per gram to have, this is the cell concentration during consumption, then you can define this as probiotic products. Nowadays, you find a lot of probiotics, and every year when I go to the United States, I find the shelf of probiotics is almost doubled. They have a lot of probiotics nowadays. It's a huge business. And they help, like example, we said that colon health for daily probiotics to have a balance with gas, bloating and constipations and diarrhea. They make a microbial balance in our body. They have one probiotics for kids, they have probiotic for women, they have probiotic for elderly. And this business, which is huge business, which is growing up nowadays in terms of capsules. In addition, the newest trend now to have a probiotic for skincare, and the toothpaste and the vaginal wash, all those things are new products. They were not exist in the market 10 years ago. But now with our increased awareness about the probiotics, but these formulations is very sophisticated because if we need to have active microbes on the shelf, which is dormant cells, but not dead cells. Therefore, they are a big challenge now in probiotic market for this type of non-dry formula. Probiotic for animal feed. Nowadays, in the world, now maybe in Southeast Asia, to try to have some enforcement to reduce the use of antibiotics in animal feed. Because of the microbial resistance nowadays, it will be #1 killer in the world within the next 20 years. They said the new microbes will have a resistance for the non-antibiotics because of we extensive use antibiotics in animal feed. Now, the only choice, I need to enhance immune system through probiotics. And even for me, I had a couple of projects we run nowadays with companies for probiotic feed. And we have some collaboration now with University Negeri Jakarta as well for this trend. For probiotic food is known like in yogurt, coconut kefir, sauerkraut, which is very famous in Europe, especially in Germany, kombucha, kvass, natto, and raw cheese and kefir. They are the grade 8 probiotics products known currently in the market. We have also kimchi, we have pickles, we have fermented sausage. All those are using probiotic microbes and going to be probiotic products. The market of the probiotics reached 20 billion by 2020, and the mass of the probiotic business focused on pharma, food, and feed industry. And this market is growing very fast, and they absorb whatever new technology, and therefore, most of the business is now going in this direction. Global market for probiotics in a sector-wise, they go in a functional food, dietary supplements, and animal feed, but the animal feed expected to grow more nowadays because of the enforcement of ban of using antibiotics in animal feed. Therefore, the choice now, or the first choice, they use probiotics, which is to prevent the death of the newborn chicken, like example, and also to prevent, as a prophylaxis, to prevent another animal diseases. If you look for probiotic business partners, I say microbes are business partners. We are under 3 categories. We have lactic acid strains, which is mostly are facultative aerobic. Then I have anaerobic strains like bifidobacterium, and I have other one, which is yeast, like Saccharomyces boulardii, and I have Clavieromyces lactis, and different types of microbes, which is in our body. But most of the microbes usually in intestine. And but the most functional microbes now, the people look for non-intestinal probiotics. They look for stomach probiotics because nowadays we have also some microbes, they can survive in stomach, against Helicobacter pylori, then it will prevent stomach ulcer. This is one of the growing business nowadays. If you look for probiotic, they have ability to survive in the extreme conditions of digestive tract, ability to adhere to epithelial cells in intestinal mucosa, and colonization of a potential in the human intestinal tract, and production of antimicrobial substance toward pathogens, and safety in regard for human use, and on the other hand, stability during storage. Because I store living cells, it means need to be dormant. If they survive, if they grow on the shelf, then they expired very fast, the products. If they are dead, it's not a product anymore. Therefore, we need to have this balance between both. Then, by process design for probiotics, I have a microorganism. We look for the type and thermoadaptation, dryness adaptation. Then we have a production facility, upstream and control system, cultivation mode and scalability, downstream requirements, and products formulation. These are the 5 main things I need to consider once come to the development of probiotic products, which is to say, I have a complete platform for the production of probiotics. One microbes I'm going to talk about the medicinal yeast or biotherapeutic yeast, which is Saccharomyces boulardii. When we're talking about the process, Saccharomyces boulardii, they don't have a long history in industry, but the cousin Saccharomyces cerevisiae, which is the bakery yeast, is very famous. Then we need to develop a platform for this one. But why Saccharomyces boulardii? They inhibit the pathogen attachment, inhibit the action of microbial toxins, and stimulate immunoglobulins A, and at the same time, trophic effect of intestinal mucosa. Even though being basically I'm a microbiologist, I don't know a lot about Saccharomyces boulardii during my study, but my interest on Saccharomyces boulardii started in 1997. At that time, I was doing my PhD in Germany, and I went to my doctor to have some treatment, and I told him during our chat, next week I go to US for a conference. And he said to me, okay, it's better for you, Hesham, if you take Saccharomyces boulardii, I prescribe this for you. Just take 1 capsule before you travel, and every day during your travel, take 1 capsule until you come back. Then you will be not having any problem with diarrhea. Before I was wondering, is this special Saccharomyces? He said to me, yes, it's not the Saccharomyces cerevisiae, it's boulardii. Since that time, I had interest on these microbes. Okay, again, if you look for Saccharomyces, it's called the most wanted yeast. Why? Because Saccharomyces help to feed 6.3 billion people. Okay, we are in Southeast Asia. We take more nasi, no roti, too much. But now people change even in the food style, and they use bread. And Saccharomyces cerevisiae, we have a global market size of 430,000 tons of dry solid yeast per year, and save life of 150 million diabetics because of its use for induction of insulin and production of recombinant protein, and produce drug and vaccine for other 100,000. It means Saccharomyces as a strain is very important for human life. But the challenge here, to develop high biomass of Saccharomyces boulardii, I need high cell density for Saccharomyces boulardii. On the other hand, I have ethanol inhibition effect. On the other hand, I have to produce high cell density cultivation and prevent ethanol during the high cell density cultivation, and need to adapt this strain to dryness. Why? When we're talking about the production process, we think about costing. How to convert the cells from liquid form to powder form, or suspension form to powder form. I have either spray drying or freeze drying. Freeze drying is the best, but very expensive for industry. Therefore, we develop a process how to make spray drying of yeast without significant loss in the activity. When we are talking about the bioprocess optimization, we go from determination of process bottlenecks to bioprocess optimization of lab scale, scaling up of the process, then we go to downstream. The logo in the top, I like it too much because I designed this logo almost 20 years ago. After finishing my PhD in Germany and going back to Egypt, I helped to establish new scientific city called City of Scientific Research and making people to understand what's the bioprocess development about. I designed this logo. This is a bioreactor. We convert from DNA to a dollar sign. Means I convert in a bioreactor from scientific value to a business value. And this is the rule of the bioprocessing people. For this process, we have different bottlenecks. We have glucose repression. If I add a lot of glucose, this is the photo of the first bioreactors I used to cultivate Saccharomyces boulardii, which is in Egypt. But after this, we develop here the complete platform now in Malaysia. We have from glucose repression problem, oxygen limitation, mixing and aeration. I have a problem with the foaming effect. I have a problem with the mixing and the pH control. Then I need to consider all those my bottlenecks when we design the process further. The initial cultivation was going like this. A biomass going up of a cell dry weight, maximal biomass of 2.5 gram per liter, which is very little if I'm looking for a biomass. The pH drop, this is a typical yeast, and then it's increased again once the cell enters stationary phase. This is in shake flask level. And for this one, in a shake flask and a bioreactor, it's different, looks different, but the biomass is almost the same. The upper one is the shake flask, the down one is the bioreactor. Then 2.5 gram per liter, it's not a business at all. Then we need to optimize the process. The second stage, we go through cultivation in a defined medium supplemented by 2 gram per liter yeast extract. Just I would like to share with you, keep in mind, yeasts love yeast. Means if you need to cultivate a yeast, just put yeast extract to initiate the growth. This is a typical cultivation strategy we usually do. Therefore, once you just put 2 gram per liter, we increase the biomass up to 5 gram per liter. It means I double the biomass in the bioreactor. Dissolved oxygen not limited. It means I don't have oxygen limitation, but I have glucose limitation in this cultivation strategy. Then it came in my mind, it needs a feed batch cultivation strategy, which is we design feed batch cultivation strategy in a small scale reactors, and we go from batch to a feed batch with increased feeding rate. We increase the feeding by time and we reach 35 gram per liter. You remember, we start with 2.5 gram per liter. Then we reach 35 gram per liter. Furthermore, we reach a feed batch cultivation with increased feeding bulks of yeast extract. Bulks feeding of yeast extract by time, monitoring the dissolved oxygen and outgas analysis, we make its maximal biomass 85 gram per liter. We start with 2.5 gram per liter. By this value, we can say it starts to be economic for large scale production. Once we go further, we develop an equation for high cell density cultivation. Actually, it started developed 1992 by Kurtz, and then I redeveloped this equation to be used by fungus and yeast in 1997. And we consider maintenance energy, specific growth rate, volume of the reactor at the time of feeding, the biomass at the time of feeding, exponential of the mu set, which is the set value of specific growth rate, integrated temperature over the temperature, time over time of feeding. With this one, we programmed a certain pump to having exponential feeding in this process. By this cultivation strategy, we reached 120 grams per liter biomass, which is the maximum we can achieve in this process. And this become high cell density cultivation of Saccharomyces boulardii process, which is we developed and we published this many years back, but now we scaled up this process. This is the first platform I developed. It was a long time ago in Egypt. And this was from the cell bank, small flask, 15-liter fermenter, 70-liter, 300-liter fermenter. We have a cell separation, cell washing, spray drying, and a powder form. Currently in UTM, we established the same platform, but up to 1,500 liter. It means 5 times of this bioreactor. And we work now with this process as it's developed and mature process nowadays. If you're going to develop high cell density cultivation strategy for a bioreactors, means for industrial scale, we need to keep in mind, we need to have efficient system to have maximal oxygen transfer. We need to have efficient cooling system because of the growth is exothermic, and we need to have a good cultivation strategy for that. Efficient control of the irrigation agitation, oxygen supply, if needed, need to sparge with the pure oxygen, high quality outgas analysis system, and efficient control for dissolved oxygen cascading, high efficient control system for irrigation agitation and substrate supply, and online turbidity meter for online cell growth determination. And then based on this, we established a complete integrated platform for biomass production of high cell density cultivation. This was the first platform. The second platform we developed was selenium enriched Saccharomyces boulardii. Saccharomyces boulardii, they have a functional, many function in human health, but selenium nowadays is one of the very important minerals which is needed for elderly. If you, some people now, for old people, they use a product like Centrum, which is multivitamins now widely used worldwide. And we have a Centrum Silver. The Centrum Silver, they have a selenium. Selenium is very important for human health, especially related to osteo, which is the bone, and also for a memory. Nowadays, there are many theories that selenium in signaling is very important in neural system. But if you use selenium as inorganic selenium in high concentration, it will be toxic. And to be absorbed easily in human body, we need something called organic selenium. The selenium need to be combined with something organic. And the best one is Saccharomyces boulardii. In Saccharomyces boulardii, first, we need to determine selenium toxic effect and how selenium can affect the growth. When we add selenium to the medium, we add different selenium concentration to develop this process from 20, 40, 60, up to 160. And we find 100 milligram per liter selenium is the most suitable one. Otherwise, increasing selenium will decrease the biomass. Then we say, based on this process, 90 milligram per liter even was selected as the optimal selenium concentration, and resulting of 21 of microgram per gram selenium accumulation in the cells, and the biomass is 4.3 gram per liter, which is give me a new product, which is selenium yeast, which is highly needed now in food and feed industry. Then we need to study the addition time of selenium. Should I put selenium at 0 time? Or I make the cells grow first, then I put selenium. We realized that the best addition time was 16 hours, followed by cultivation 24 hours. It means I add selenium after 16 hours, then I keep the cultivation going for 24 hours. By this cultivation strategy, we can reach 39 microgram per gram of selenium, and we have a higher biomass production. Then this is toward develop a new products for selenium yeast. Then when we go to the bioreactor level, we do the same. We do the run of the cultivations for 16 hours, and then we add selenium after 16 hours, but we calculate the rate of selenium absorption, which is adequate rate 1.43 microgram per gram per hour. Then I have here scaled up the process, and we have a biomass which can reach here about also 6 gram per liter, which is for this process considered acceptable in this scale. And we tried after this to scale up of this process. We came in mind, okay, why to put selenium in a bioreactors? Why not to take normal cultivation of Saccharomyces boulardii? Because before we can reach 120 gram per liter, and then I just mix selenium like bioabsorption and selenium accumulations in the cells, which is also another platform we can consider. And by this platform, absorption of selenium was less compared to if you cultivate the cells with the selenium. Growing cells can use selenium and accumulate more effectively, almost 50%. Sorry, it's almost between 40 to 50% higher compared to the normal conventional way if you just put a selenium with the yeast for bioabsorption. Then we develop a platform for selenium yeast in batch and feed batch cultivation in semi-industrial scale. The first strategy in semi-industrial scale bioreactor, 16 liter, for the maximal biomass achieved for 7.81 gram per liter for 30-hour cultivation. Then the maximal selenium accumulation reached 31.81 microgram per gram. Then with these platform cultivations, we can start to optimize a process in the batch cultivation. This is under uncontrolled pH. Then the other process, when we have a feed batch cultivation, we reach 25 almost gram per liter after 54-hour cultivation. It means I have now two cultivation strategies developed. One, if I need just to produce Saccharomyces boulardii without selenium, then I can up to 120 gram per liter or 85 gram per liter with a simple feeding strategy. Or the other strategy with this highest value, with this higher value in the market, selenium yeast, because of selenium yeast price is much more higher than the normal yeast, then I can reach up to 25 gram per liter in a very simple feed batch cultivation strategy. This is a comparison in a biomass. We in a bioreactors also almost 7.7 gram per liter. We reach almost 25 gram per liter, and maximum selenium content increased here 41 microgram per gram. Specific growth rate increased in the feed batch, and selenium absorption is become higher, microgram per gram per hour. This is the second platform we developed for probiotic yeast, selenium yeast. The third platform we developed for high biomass production of marine probiotic yeast. This is for aquaculture business. And for this specific marine yeast, this was isolated from the Red Sea, from Hurghada area in Egypt. The Red Sea is different from other seas because of salinity is very high compared to the open ocean. And also the flora of the Red Sea is very unique. Therefore, we start a platform for isolation of probiotic marine microorganisms from the Red Sea in collaboration with some colleagues in Egypt. And they isolate the yeast, identify, characterize, and then they ferment in small scale. They give to us in Malaysia for scaling up. This is an international platform. We do like this. We nowadays, we work not in one country. The same we do with University Negeri Jakarta, with the group of Prof Mokti and Dr. Dalia Sukmawati. We do in this type of collaborations. First, we identify this type of yeast to ensure this is a safe type, which is under Cryptococcus. And we give in the name strain YMHS, which is the first name of each of us in the group. And this is as a new strain, which is deposited in a cell culture. The first things we look for hydrophobic properties of these strains. Not only tolerance in saline, in bile saline solutions and a different pH like the normal one, but we look for hydrophobic. They have a capacity to absorb or not. And there are in vitro study, which is very simple, using chloroform, ethyl acetate, and xylol. And we realize they have a capacity for hydrophobic properties of the Cryptococcus, then they can adhere to epithelial cells. We start a cultivation strategy in submerged cultivation system in a shake flask. And then we go to the bioreactors. We go to up to 6 grams per liter in 16-liter bioreactor. Then we make a simplified feed batch cultivation strategy with just increment on the feeding rate based on some calculation from the batch. We control dissolved oxygen to increase the monoglucose feeding strategy, and we reach a biomass about 30 grams per liter. And these consider, compared to other cultivation strategy for marine yeast, consider very high. And we are now developing products based on this type of yeast for aquaculture feed. Microbial platform in IBD, which is, I would like just to share with you, in our facility here in UTM, in IBD, Institute of Bioproducts Development. In my lecture, when I say from cell bank to bulk powder, finished product, we do all here in this platform in collaboration with industry. Industry usually need one-stop center. They don't need you to ask, do this step in this center, go another step for other center. We start from a microbes, from cell banking, under wellness industry culture collection, which is non-pathogenic microbes. We never put any pathogens in our cell bank. And then microbiological and analytical laboratories. Then we have an upstream, we have 5 16-liter bioreactor. Then we have another platform, 16-liter bioreactor and 150-liter bioreactors for optimization of the process. Then we have another platform, 16-liter, 150, 1,500-liter steric tank reactor. This is fully industrial scale for production. For the downstream, we have high pressure homogenizers with the self-clean separators to separate the cells if it's needed. Then we have spray drying and freeze drying. Then we give a complete finished products from our institute when we have industrial projects with any industrial partners in Malaysia or outside Malaysia. I just would like to share with you, in January 2021, I'm just first time to announce, we're going to have a book called Probiotics, the Natural Microbiota in Living Organism, Fundamentals and Application, which will be under the CRC Press in the United States, edited by myself and Professor Yang from Ohio State University. And if any of you, our colleagues in university, especially University Negeri Jakarta, and other colleagues who attend this conference, if they need to have a copy from this book, please just communicate with Prof Mokti or Dr. Dalia Sukmawati, and we just I can help to have a special discount for you from CRC Press, only from our friends who are attending this conference, to say thank you very much to having my talk today. Working alone, I say, usually bring nothing. You need to work in a big group with a strong network. I just would like to acknowledge our big team from IBD, Dr. Daniel and Mr. Shanmuga, who's doing a probiotic now, very attractive probiotic in treatment of stomach ulcer, and Roslinda Malik, Mrs. Afif. She just finished her master with a probiotic. Linda is also did master in probiotic. Jennifer, she was working in industry, and we worked together for industrial projects for probiotics. She finished her master. Now she worked in very attractive topics, which is probiotic from insects, which is we start this new platform. Mr. Saleh, he's our industrial guy, and Dr. Siti Zulaiha Hanafi, and many others from IBD. Dr. She's one of our industrial partners in Malaysia for probiotics. Mr. Vic, this is a company which is they use probiotics in their feed nowadays in Malaysia, and we had a project with them. And our beloved friends, Professor Dr. Mukti, thank you very much for our collaboration and kind invitation. Dr. Dalia Sukmawati, my moderator today, and we are working since 3-4 years now. And every year we have a lot of publications together for University of Jakarta and the UTM. Professor Mahdi Milawi in Egypt, Dr. Dua Abdul Rashid, Engineer Saleh Said. They are the first people who start with me a platform in Egypt about industrial production of probiotic back to the year 2005. Professor Ashraf Ilbaz from Sadat University and Professor Yusreya from Enshasy University. We established the first our publication with the marine probiotics, or isolate the strain from the Red Sea, from Hurghada area. Professor Rajni Kaur from Lund University. We did some collaborations also for probiotic, and Dr. Syed Ahmed Syed from King Saud University. And with this a big family of probiotics, we work and move together for development of new products, new technology, and students who learn from this platform. And I'm proud to say they are now work in many fermentation industry worldwide. With this, I would like to thank you very much. And now in the right side, this is exactly where I am sitting now, in this area. This is my office, Institute of Bioproducts Development. And this is 2 big buildings, also Institute of Bioproducts Development. And we have our students, our pilot plant is here. And we are very happy to receive a visit from you. Hopefully, once this COVID-19 is over, inshallah. And we are looking for a bigger family, and anyone is welcome. This was my alarm that I finished my on time. And with this, I would like to thank you very much.
Thank you very much, Prof. Hesham. It's very great presentation. We have whole package about the probiotic, from the cell to the powder, how to use this product to be marketable. So it's very nice, very great presentation. Thank you very much. We have 241 our participant in this our rooms, and I think they are very interesting what are your presentation delivering today. And we have so many questions here. I will read to you. From Prof. Tati Kusniati from Indonesia Institute of Science. She asked me about, I would like to know why you use probiotic yeast, not probiotic lactic acid bacteria. And with the same question from Prof. Tatik is, as long as I know, probiotic lactic acid bacteria is much more than probiotic yeast. Maybe that's 2 questions first, Prof. Hesham, please.
Okay, thank you very much. It's very nice comment. What I presented today is only the probiotic yeast in our platform, which is unique. But probiotic bacteria, I think we have also established 6 or 7 platforms with many students. They did acidophilus, lactic acid, lactobacillus acidophilus, KZ, and we have bifidobacterium. We have many students, they run it. The functionality is different. Therefore, we focused, I just highlighted to you today, the probiotic yeast. The probiotic yeast now in the market is less known compared to probiotic bacteria. There are 2 advantages of probiotic yeast. Number 1, we can adapt a little bit to dryness, then we can use spray drying technology. Number 2, this competition, and they have some signaling in the intestine to prevent diarrhea. This is the probiotic yeast. Therefore, one of the main issues for human and also for animal is the diarrhea during husbandry of animals and farming. Therefore, probiotic yeast now become very common in the market. But again, for sure, lactic acid bacteria still there. And usually in our new formulations, we're going to have the 3-in-1. The 3-in-1 is lactic acid facultative aerobe, then anaerobic bifido, plus the third one is the yeast, Saccharomyces boulardii yeast. The other advantage of probiotic yeast, the high absorption capacity of organic selenium. It's meant for selenium, to make organic selenium. We fail to have organic selenium using lactic acid bacteria. Therefore, we like, when you're going to have organo minerals like zinc, organic zinc, or selenium, or organic selenium, and all those things, the best platform is to use a yeast, which is Saccharomyces boulardii or Cryptococcus, as I mentioned, and other microbial strains. But for sure, lactic acid bacteria still one of the main key players in probiotic market.
Okay. Thank you, Prof. Hesham, for very nice. I hope Prof. Tati will have a new idea to do the research, because I know he is better in the probiotic too. And the next question from Agus Saifuddin, Universitas Negeri Jakarta. How to measure effective and efficient for quality probiotic product in your experience?
Yeah, functionality is one of the main issues. If you're talking about functionality, they have 3 things you need to think about. Number 1, the number of final living cells in the product. The number 2 is tolerance to the bile salt, then they can reach the intestine, and the tolerance against the pH. These are the 3 main criteria. Some other one, which is if you have new antibiotic or new probiotic, we need to test adhesion capacity of this type of microbes. Therefore, if you're going to cultivate let's say lactic acid bacteria, KZ, acidophilus, thermophilus, whatever, you don't worry too much about adhesion, because they adhere to the intestinal membranes. No problems about this. But your main worry is your formulations, this type of cell you produce, can reach the intestine or not. But if you isolate a new probiotic to claim it's a probiotic, you should to have in vivo and in vitro adhesion test. This is what we did with this strain, which is Cryptococcus, which is isolated from marine. And this was in our learning curve. We must do this test before you claim it have any probiotic properties. This is stage 1. Stage 2, you need to have experimental study, which is running now with the tilapia, with the Fishery Research Institutes and National Research Center in Egypt, for this to ensure this Cryptococcus is worthy to have in a product. And they give a very good, promising result in preventing some fish disease and also increase the weight of the fish. Because of this is in this business is pro and con. Why you pay more for your feed to have a functional feed, then you should have a value. And this value is increasing the yield and reduce the disease. And this is the job of the probiotics in general.
Okay, thank you very much, Prof. Wow, it's very remarkable. And the next one is very interesting. But the question is, Halim Syekh Kuala University, how this topic we apply to basic education?
I love this question too much.
Yes, of course.
If scientists not deliver the message to the public, means for me nothing. We should to educate people. We should to, when we say to the normal people on the street, they need to understand what's the value of probiotics. Because this is very healthy alternative for human life, for the quality life. Extensive use of antibiotic nowadays and extensive use of food supplement, which is non-safe, which is very critical. Education, education, education. We educate students, and with education, our students will be our ambassador to the society. I cannot reach each village, I cannot reach each corner of the city to give a talk. But if you educate, and we can say a platform, healthy life ambassadors, who are our students. Okay. We teach them how to live healthy, not only with the probiotics, with natural products. Those prophylaxis, I cannot say therapeutic, because of therapeutic, it's another story. They need a lot of many years to have a regulation to say, I treat instead of the current medicine, which is, I never say that now. This is just a prophylaxis for healthy life. And what's the value to have a chicken not fed with antibiotics? I just use a chicken fed with probiotics, which is natural, and I'm going to have a natural feed, immunoenhancers feed, and other topics that we can have. Therefore, if you're going to have within your curriculum, not just teaching them what you need to teach, but teach them how to deliver the message. And put this in their curriculum, they need to go in a village to teach people there how to have a healthy life using the microbes, or to have a nice fermented food. I know Indonesia is very, very rich tradition of fermented food, which is the healthy food, which is, I know Dalia is smiling now, Dr. Dalia, because she do a lot of these things. If you give this to the society and teach them, then it will help a lot. And I think this is what we need in nowadays, especially in many developing countries. I don't like to say we are in developing countries because of I don't believe on this classification too much, but could be developing in economy only. But in culture, we are much more developed than many countries as well, okay? Therefore, I totally agree with this question. We need to have integration of this knowledge in our curriculum. And for me, I'm one of the Family University Negeri Jakarta. I love to be saying like this. And anytime, if there is a seminar, a talk, put me in your curriculum. I will be very happy to deliver a talk to your students. Okay. And wow. Dr. Dalia is there, and many of our collaborators in probiotics are there. And I love too much to see this knowledge is cascaded down to the society, and the people start to understand what's the value of probiotic in their healthy life.
Okay. It's look like a good idea to collaboration, education, and scientists, isn't it? Yeah. Wow, it's very great. We will do it, inshallah. Inshallah. Thank you so much, Prof. Hesham. And this is another question, but from Cecilia Cordayanti. You said about if we compare two yeast, Saccharomyces boulardii and marine yeast, what is the advantages and disadvantages of yeast in bioprocess economic health, or maybe other point of view? Thank you very much. If you are combined two kind of yeast, what do you think about that?
I totally agree about this question. It's very nice because I believe too much on a consortium of probiotics, not only one type. But Saccharomyces boulardii is widely used for terrestrial and terrestrial animals and for human because this is one of the natural flora in some fruits. We can isolate Saccharomyces boulardii and some fermented products as well. For why we isolate from marine yeast? Marine, it means survive under high salinity. Mm-hmm. Saccharomyces boulardii cannot survive under high salinity. Oh, okay. The functionality of marine yeast in adhesion to the intestine of fish is different from Saccharomyces boulardii. Therefore, if you need, like example, now I have a new project, long-term collaboration with one of the key players actually in the world for cultivations of insects for human and animal feed. And we isolate now new strain from the insect gut because I need to use to improve the life of the larvae. I cannot give traditionally human probiotics to the larvae. Oh, okay. I need something which is compatible to them. Sometimes it's work. Like example, lactis, acidophilus, whatever you give, it's work. But the best, if you isolate from this environment, especially if it's different environment. Marine environment is different from our normal environment on the earth. Therefore, when we'd like to have marine probiotics, which is currently booming business, I think when people hear, I think a lot about aquaculture feed, aquaculture probiotics feed. This is now, it's huge, especially in Southeast Asia. They are one of the main exporters of shrimp. And now Europe or United States not allowed to import shrimp if it's having a feed with antibiotics. Now the probiotics, if you Google just probiotic feed for aquaculture, it's huge business nowadays, and it was one of the very nice niche area. In addition to that, it have some cleaning effect, detoxification of chemicals. They claim that sometimes. If you put probiotic feed to a pond, they can do also bioremediation activities. But there are some study for this. We didn't run this study, but there are some other claims of using, other advantage of using probiotic marine microorganisms.
Okay, Prof. Wow. It's the same question with the previous one. It's from Dr. Trihandayani, Universitas Negeri Jakarta. And for Dr. Ratna, it's the same profession. She asked me about, is there any possibility that as a probiotic, Saccharomyces boulardii can be used to increase the immunity to against COVID-19? Because this is very pandemic and we are very scared about this one. How can we increase our immunity? That's very correlation. Is there any correlation for probiotic and our immunity?
Yes, I like this question too much because the business of I say the business of COVID-19 is beyond the mask and detergent. Okay. Yeah. Now everyone think about health supplements. How? Because of, they say the same person has got the same COVID dose, or that's one is got infected, another one no symptoms. It's known. Maybe the public people, the people in the public say, oh, it's surprised. It's a surprise. It's a new virus from one to one different symptoms. No, this is microbes. This is normal. If my immune system is down and your immune system is high, and we both exposed to the same load of microbes, I will be more sensitive, more symptoms come to me. Then the only things to keep you healthy, your resistance against pathogens need to be high, immune system need to be high. Why? It means healthy food, less pollution, and something enhance your immune system. Probiotics is known to be immune enhancers. They enhance immune system, number one. They have different mechanism. Even they have some antimicrobial properties, as I mentioned today. Lactic acid bacteria, they produce niacin. Niacin is very known. And bacteriocins, which is peptide antibiotics, are produced by lactic acid bacteria in our body to prevent a disease. This is very simple, not only in our body, even in the soil. If you kill all microbes in the soil, pathogens will be flourished easily. If our body not have a microbes, we can die easily because of no resistance, no soldiers, no one to protect our body, no army. I said microbes are our army against the disease, foreign disease or foreign microbes. Therefore, I totally agree. Enhancing immune system, there are different mechanisms we have. I just talked with you today, one of my babies, which is probiotics. I have my lovely baby, which is mushrooms, which is I also developed many platforms as immune enhancer. And all those together is a solutions to provide natural solution, how to enhance immune system. Probiotics and other ingredients, but again, I cannot say and claim to say this probiotic against virus or COVID-19. No. The claim is immune enhancer. Yes, it's proven to enhance immune system. As I mentioned to you, it's prevent diarrhea. How it's prevent diarrhea? It means if you go from one country to other country, you have the normal different E. coli, non-pathogenic E. coli, but they can make a diarrhea for you because of the E. coli from one country is different from the other one. You in Indonesia used to your own E. coli in the food or in the environment. When you go to other country, other parts of the world, it's affecting you. For me, even I'm Egyptian, but 13 years in Malaysia, when I go to Egypt, I feel my stomach is not okay for 1 or 2 days until my memory still okay. My microbial memory and my body memory still to readjust again. When I go to other countries, it's the same. But to minimize this one, probiotics help a lot. Therefore, I totally agree. Having probiotics supplements in general, it could be a generic solution for many diseases to enhance immune system.
Okay, Prof. Hesham. It's very nice presentation and it's very nice explanation. So the time is up and I can realize this one. Our committee said to me, Dalia, you have to stop it. Oh, very nice. Thank you so much. So thank you so much for all of the participants in this room. I hope all of you have a completely about the probiotic, how to produce from the cell to the powder. How can we have to this sign equipment? If we don't have equipment, we can do collaboration research, like Prof. Hesham said. Thank you so much for this very great presentation, Prof. Hesham. And once more, we will love that your books. Maybe some of participants will buy from this book and have to discount, isn't it?
Yeah,
Okay.
the book you are, as I mentioned,
yes.
lovely. I'm going to share with you. Sure, Dalia, you are the first one I'm going to share with.
Thank you.
And thank you very much. When I see now with Jakarta, I miss Jakarta. I miss University Negeri Jakarta.
Okay.
And hopefully, inshallah, everything's going to be passed over with this COVID-19. And we meet again in person for more collaboration with new friends coming from this conference. Again, thank you all. To see 251 have seen my lecture. It's big honor and proud for that. And thank you very much. Thank you,
Thank you
Dalia.
so much. Thank you so much, Prof. Hesham. Thank you so much for all of the participants. And for this time, we will invite you to fill the attendance from on the link. And the time is over, Prof. Thank you so much for all of participants.
Okay.
Have a nice day
Bye
and
bye.
have a
Thank you.
healthy. Bye. Thank you
Bye.
so much.
Thank you.